Welcome back to another episode of The Factory. We are continuing our Design a Product With Us mini-series where we are designing a PiicoDev servo driver. In the last episode, we labored out a Hello World example from this little hardware prototype, which is a Adafruit breakout board that has the same chip that we want to use, and we were able to see some signs of life from this servo driven over I2C. At the end of that episode, I mentioned we had a forum topic live where we were going to seek some of your assistance in designing this product. In this forum topic, which I've linked in the description for this video as well, we explore a couple of hardware ideas for how we might execute this module, specifically how to handle the high power connections. Servos are quite happy to draw in excess of an amp when holding torque, and the little PiicoDev cables that we use for our small signals and low power modules, they're probably not going to cut it for, upwards of 2 or 3 servos. So a very important first step before designing this hardware is to take a look at this feedback and decide on the topology of this module. How we're going to deliver power to it in a easy to understand, cost-effective, and kind of sustainable way. Like, we don't want to have to introduce lots and lots of adapters, etc. Let's get to it. We're on the forum topic, and this is idea 1, where we're using USB-C just for power. So in this use case, we have our PiicoDev development board, in this case a Pico. We have our normal daisy chaining. We can daisy chain through a servo driver, through another servo driver, and then continue with more small PiicoDev modules, more low power modules. This idea works because we have external power coming in this case with the USB-C connector, and power is daisy chained separately. So we have 2 PiicoDev connectors on each driver and 2, in this case, USB-C connectors on each driver, so that we can daisy chain power off to another module if necessary. And that's kind of a big deal already. This servo driver ought to be able to take care of most makers' needs in the first place. So getting that second servo driver, you're probably talking about some pretty serious projects here. And so the burden here is that we have 2 interconnects between each module, and one of them is a USB-C cable, which is, not quite as bendy as these tiny PiicoDev cables. But very simple idea and very easy to understand. You got a daisy chain PiicoDev and you got a daisy chain USB-C. Idea number 2, USB-C for everything. If this could work, it would just be the dream for me, honestly. This is a slight variation, but very important. This looks very similar to idea number 1, except there is no second cable daisy chaining the PiicoDev modules. We have USB-C delivering power, we have our PiicoDev bus, and they are combined into a single cable that goes between servo drivers. Because this USB-C cable could potentially carry the I2C signals, the 3-volt power, and the high power, the 5-volt power for these high power accessories. And then once we get back to the end of our run, we can fan out and just bring out a normal PiicoDev bus. This was really my pet idea, and we'll see why it might not work. James came in with a very helpful post that kind of got me quite excited for this USB-C for everything idea. This debug accessory mode that's available for USB-C means that you can basically say, hey, all the data pins are for test purposes only. And so a host device like a computer will just not interact with those pins. That means that we could potentially squeeze, 5 volts on V bus. We could put the I2C bus in these test pins, as well as the 3.3 volt power, because it's low power. It's starting to feel a little bit risky though. Like, could we introduce damage to other people's devices? This debug accessory mode, it feels like it's more of a production test, a production environment test, than it is a to be released into the wild type application. Honestly, you guys hated idea 2. I don't think anyone in the forum was in support of idea number 2, which brings us to idea 3, which is still a very easy to understand idea, I think. We have the servo driver, we have some high current interconnect, so not this normal standard PiicoDev cable, but some beefier, maybe JST type, like a JST XH. And of course that would need all the conductors you did. 3.3 volt, 5 volt, the I2C bus, the ground. So this would be like a deviation from what is normal for PiicoDev, which is why I kind of hate this idea. But we have to consider it. We have to consider that it's very easy to, bring in an adapter and adapt to this. It just means that if we want to have small modules coming off the other end, we need a second adapter to kind of convert this large connector back to the small PiicoDev connector. While this is very easy to understand, there's probably more burden with this idea than with idea 1. And just to reiterate, even though we're starting PCB design today, it's not too late to get your ideas in on this forum, because we're just doing some prototyping. We're just seeing how various ideas feel, whether we can even fit a design onto a 2-unit PiicoDev module. So get in there and let us know your thoughts. So this James votes for idea 1, but with an alternative power option for the USB-C connector. Idea 2 introduces some problems due to non-standard use of USB-C pins. I agree. As much as I love the idea, I agree. It's probably too high risk, and having power go over those data lines is probably just asking for trouble in the wild, right? Idea 3 is idea 1, but on a separate board. Yes, it is, with the intention being that the adapting burden is worn once and not on every single PiicoDev board. Maybe? Idea 3 is idea 1, but on a separate board. It is. It's actually probably worse than idea 1 because you need additional hardware at the in and the out point. Jeremy also votes idea 1. James votes idea 1. A lot more support for idea 1 than any other idea. Okay, so until further notice, we're going to proceed with idea 1 for now. Of course, everything is subject to change. This is just a prototype. We're going to see if we can even fit it on the board, but I think we might as well get cracking because small changes like swapping one connector for another are not a big deal if we decide we don't like that user experience. Okay, so I've opened my 2-unit PiicoDev template. This is what the empty board looks like, and we have a lot of placeholder stuff on the schematic, and we're ready to begin populating. Okay, so here I'm putting down the I2C device. This is the PWM driver, and connecting up the I2C bus. That's the SCL and SDA lines. Just referring to the datasheet for some typical application information. Now we're putting down the servo headers for the servo channels. And there's a little bit of a bug on the screen here right now, but we pick it up later. Don't worry about that if you've noticed. We set the addresses all to 0 for now. And I'm just putting the part on the PCB just to get a look at whether it's going to fit. So I'll probably just drop down a resistor and connect that to ground. And 10K sounds pretty good for that. We're already using 10K elsewhere in the circuit for both the pull-up resistors and the LED resistor, which is pretty crazy. You don't see this very much where you drive an LED with 10K, but the LEDs we use are insanely efficient. So that's good part reuse. Just having a look at these connections here, if there's anything that we need to do to signal that we want power, but it looks like with USB-C, it's just the downstream facing port that advertises how much power it can provide. And that is done using these RP and RD resistors. But since this is the device, it's not the current source, I think we are just right to proceed with this very basic setup. And stretch goal, we'll see if we can add some breakouts. I want a 1x2 on each. And that'll just be good for prototyping, debugging, etc. It's a good idea to run the ERC, the electrical rules check. That's this button in KiCAD. And when we run this, oh boy, do we get a lot of errors. Usually administrative stuff like power ports, etc. For example, every single one of these pins I'm getting spanked for because it is left unconnected. So we will intentionally leave a non-connect flag there. You can do that quickly with the Q key. We rerun and we're down to much fewer errors. I haven't annotated my schematic, of course, so I'll ignore these duplicate items. This is an interesting one. You'll probably always see this. This is when you have an input power pin not driven by any other pin. So that's referring to this 5 volt here. And that's a bit of a metadata hack to fix that. Here, you need to attach your power net to a power flag. So if I take that 5 volt power net and I just grab a power flag, what we're doing is we're just indicating that there is power coming from somewhere. So when I run the ERC again, that error is removed. And we basically have, aside from this one, we have only annotation errors. So I'll annotate my schematic now, fully annotate, run the ERC, and we have no errors. That's always a good place to start because, hey, you could have misclicked and you could have thought you made a connection where there is none. And when you get your PCB delivered, there's just a trace that doesn't exist because you never designed it in the schematic. And so when you get to the board layout, you don't see the rat nest that you're meant to connect. So a good PCB starts with a good ERC. And we are ready to assign some footprints. It's nice that with a lot of the built-in components for KiCAD, there are a lot of device variants. So this part already has the right SOIC package associated with it. It's really just all the generic stuff that I included in the circuit that needs footprint assignments. So these con 1x3 males. I know I need a connector pin header, and we do have tiger claws in KiCAD. Ooh, I thought we had tiger claws. Maybe the naming change between KiCAD 5 and KiCAD 6, they just call it SMD. So I know I want a 1x3 with an SMD. So of course we need to make a decision about where pin 1 is, whether it's on the left or the right. It's probably safest for us in the long run, safest and most scalable for us to just make a composite footprint of the two so that it doesn't matter if we get a pin 1 left or a pin 1 right. We can put any part there in case we need to change supplier or whatever. In our Core Electronics Components library, we've already done this a few times with some other connectors for other devices. Notably this Makerverse micro SD adapter, we have a tiger claw header here, and we've just doubled up on every pad so that if we can't get this exact header, we can just swap to a pin 1, what would it be, left variant instead of a pin 1 right variant, and just put it straight on the same footprint. So I'm going to have to make a copy of this. We can delete this. And let's place the anchor right in the middle. So we get nice clean rotations. So that brings us back to our footprint assignment tool. Core Electronics Components, 1x3 vertical SMD, and we want to apply that to our 3 servo channels. Done. Okay, I think these I just want, these power breakouts I want as an unpopulated part, so that will just be a pin header on a 2.54 pitch. And lastly, we need our 10K resistor. I probably should have just copied one of the existing ones so I don't have to choose the part. And that is all our parts assigned. Whew. And now for the moment of truth. Is it all going to fit on the PCB? It's so often the case with PCB design that you start with a mechanical constraint and you have to fit the parts within it. As a hobbyist, you may be designing PCBs that have no size constraint. And that's lovely, but constraints are good because, you know, nothing makes a decision easy like a constraint. Just going to place these USB connectors. Oh boy. Oh yeah, I mean we got room. We got room. It's fine. But I can just see this is going to be a nice size, I think. 3 channels looks pretty good. You know, maybe we can put our chip down here because it really only has USB. I don't want the PWM crossing the I2C though, so maybe we need to snug this part up here. But this is looking promising. Look at this. We've pretty much jagged it, guys. Ladies and gentlemen. Got some breakouts up the top. Oh, I am somewhat relieved about this. This is a great reason to have a template as well. This would have taken so much longer having to do this from scratch. Drop in our resistor. Look at our CAD. Yeah, it's looking looking appropriate. We don't have any CAD, I think. Do we have some CAD? Yeah, there we go. I'll just drop in some CAD for the other stuff. But this is looking pretty good. 3 channels feels natural. Somebody did express, I think James, who works in support, he expressed that 4 channels would just be like the perfect balance, because you could imagine with 4 channels, you could have a 2-wheeled robot with a pan tilt. So let's stretch goal out for 4 channels. 4 servos. Is it irresponsible to even drive 4 servos? Probably, but hey, got options, got real estate, got options. Just gonna take this guy, Control D to duplicate. Servo 4, welcome to the party. Okay, how much can we cram in here? I don't know if that's gonna work. Let's take these away. Maybe our orientation looks a little more like this. So now we can bring this. It's quite nice to leave it centered. I don't want to violate that like pleasing visual symmetry. As well, this I2C pull-up header, this jumper doesn't have to be on the front side. It's definitely in the pro user space. And oh geez, it's getting close. Yeah, no, we're running a little too close to those USB connectors here. Maybe 3 is the number. It does seem a shame to have so much negative space at the bottom of the board, but the location of these PiicoDev connectors it's almost inviolable. It's such a strong pattern that we've developed in the ecosystem that I would be extremely reluctant to move these around. Not just for like the visual consistency and brand integrity, but also because, you know, people are getting used to that. And if we move that location, that has repercussions for, you know, mounting options that people come up with. A pretty important design feature. I'm very, very reluctant to move these down. If I did, we could recover vertical space and maybe squeeze in another channel, but I don't know if that's necessary. Let me know in the comments what you think. I'll return to the schematic for now. We'll remove servo 4. After all, we're already at 3 servos. That's potential for like 6 amps if you're really pushing things. So maybe it's more prudent to not include the ability, to just not have the option. You know, it's such a fine touch, but it would be really nice to get some CAD on this board just so we can visualize things a little better. So we're pretty much ready for routing tracks, right? But one thing that gets me just about every single time is the artwork, especially for a public-facing product. Put the artwork down first. It's like the next constraint to PCB layout. You can really paint yourself into a corner, and maybe I already have because I didn't do the labels for everything that's here. You know, we're going to need labels for these power connections. We're going to need labels for these servo connections. And that artwork, it needs to take up some space. You can't just cram all the components together as tightly as possible, unless it's like a really engineered product that's being tucked away. But this is a little more in the education space. And so we need that really helpful self-documentation. So we need some space for the artwork. And this negative space now is looking really good for things like a title. You know, we're getting a little bit crammed up the top of the module here. Maybe we bring the title down to the bottom. So we can highlight the silkscreen layer and press H to go into like high contrast mode. We can bring this text down. You know, this open source, maybe it even goes on the back layer. PiicoDev servo driver. We haven't provisioned a link for that, but we will. It looks a little bit awkward with the title split from the PiicoDev logo. It is the PiicoDev servo driver after all. That looks a lot more consistent with how we normally do things. We'll probably just give it some room to breathe, bringing these connectors down a bit. We don't want any references on the boards because we just don't need them. So I'm going to conceal all those references. It just makes for a much cleaner looking board. Yes, if you're providing support, it can be a little harder to, say, refer someone to a specific component. Have you, plugged into this pin on J1? Overall, we've found that this works just fine and it produces a much cleaner looking board. Something that I absolutely love about the open source community is that we have people diligently working on incredible plugins for KiCAD that are just making it the best free EDA or like electronics design tool available. We have this beautiful plugin to create labels called KeyBuzzard. So we've been using these a lot on Makerverse products, and they'll be making their way into PiicoDev as well. When you start to put labels on things on circuit boards, you're really locking yourself down into a name. Of course, this is a prototype, so it's no big deal, but this is going to affect the way that we produce the driver library for this device, because you want a one-to-one relationship between what you refer to in code and what you see on the board. So choosing this text, like channel 1, channel 2, channel 3, you're kind of committing to how your code is going to look, and that's always good to be aware of. I think this feels appropriate for now. Hot tip, you can put your fiducials under components. That way they don't take up additional board space. And yeah, I'm just going to get routing and we'll see how far we get. Alarm bells, what's going on here? This shouldn't be 3.3 volts. I wonder how many people picked up on that and were screaming at me this whole time. Oh my goodness. This is the whole point of the device, is to deliver 5 volts to these servos. Oh no. Oh, that was close. It occurs to me we're almost certainly going to need to provision some capacitance for these servos, both because I can see Adafruit did, so it's clearly a good idea. But we got 3 servos, we got sensitive electronics, and we've got like transmission lines, so we want some local capacitance. We already have a part on the Makerverse motor driver that I can probably reuse. I think that's about 47 microfarad. Oh yeah. Okay. Ooh. Jeez, that's large. Can't go down here. That's stupid. It's far away from everything it needs to drive. Oh no. We're maybe in a bit of trouble. Maybe in a little bit of trouble. Let's sneak up on those mounting holes as much as possible. Let's bring these down as much as possible. I don't think that's going to make too much of a difference though. Oh geez, we are going to be violating some courtyards. That's what we're up against. So, and I think that's where we'll leave it for today. There's a little bit of work to do, maybe squeezing in that capacitor or a few smaller ones to make up a bulk capacitance to help drive those servos. Drop in the tracks and we've got a prototype. Let us know how you think it's going on the forum topic or in the comments below. We'd love to have your input. If there's anything that we can change, this is your opportunity to get that feedback in. Is that USB-C connector going to be too much of a hassle, or is it really convenient for going straight off, say, a power bank? I'll chip away at this in any case and get those traces routed and prototypes submitted. And until next time, thanks for watching.